Hello everyone, welcome to our fourth Micropole Insight webinar. This is the fourth webinar in a series of 5 and handles about data and workflow orchestration. If you have any questions during the session, you can always ask them during the webinar and we will answer them to the best of our knowledge. So let me first go over the agenda real quick. We're going to introduce ourselves. We are going to explain when that you need data orchestration and workflow orchestration. We are going to show you data orchestration within Azure Data Factory, as well as a demo. We are going to show you a tip with the future with Synapse, and we are also going to show workflow orchestration with Logic Apps. So let me first introduce myself. My name is Glenn Daams. I'm an Azure Data Architect and Data Engineer. I'm working with the Microsoft Data Platform for over 6 years, and I'm mainly focused in the business intelligence platform. In my free time, I like to play soccer and I also like to walk my dog.
Okay, hello everybody. My name is Egon van den Rijt. I'm also an Azure Data Architect and a Data Engineer. I'm working with the Microsoft Data Platform for more than 20 years. I first started as a DBA and later on I did also more and more BI projects. I'm a father of 2 sons, and if I have some free time, I like playing guitar, playing padel, and playing around with IoT devices.
So, orchestration. True leadership is the orchestration of truth into action. Let's start with taking a look on why and where that we need orchestration. So what does it mean? It leads and instructs other services. So if you look at the picture and you think about an orchestra, the most important member of the orchestra is the conductor. The conductor does not play the instruments, it simply leads the symphony members through the entire piece of music. The musicians, they use their own skills to produce sounds at various stages of the symphony. So they may only need to learn certain parts of the music. The conductor orchestrates the entire piece of music and therefore is aware of the entire score that is being performed. They will also use specific arm movements that provides instructions to musicians how a piece of music should be played. In the IT orchestration, tools use a similar approach. They will not perform the actual work, but they will instruct other services to do the work for them. There are different types of data of orchestration. There are a lot of services in Azure, and if you want to combine them, you need to create flows. In the cloud, we have a lot of tools and a way to orchestrate, like for example, durable functions, Azure Data Factory, Logic Apps, DevOps, and so on. In this session, we are going to discuss data flow with Azure Data Factory and workflow with Azure Logic Apps. And Egon is going to give you more information about data flow with Azure Data Factory right now.
Okay, thank you, Glenn, for the introduction. So let's start with our first Azure component of today, the Azure Data Factory, and that's the one that will manage your data flows. As already mentioned in the introduction, on a big data platform, you have a lot of specific services that have their own qualities and purposes. Handling this data is no one-step action, it's a collaboration between services, which can be event or data-driven. Especially in the cloud, because of its agility and platform as a service implementation, the opportunities to use the best performing services toward your needs is very easy to do. Of course, aligning those different services from ingestion and cleansing till the final analysis is an important task. If you take a look at the orchestration process in the Azure cloud, we speak more of an ELT, an extract, load, and transform, instead of ETL process. If you want to position Azure Data Factory flows in the global Azure architecture, this is the part of the batch processing to the big data layer, which is a kind of an enterprise data hub. We presented this architecture in our first webinar and talked about data vault modeling of the integration layer in our second webinar. If you did miss one of those webinars, you can always contact us or starting from Monday, it will also be available on our website. If you take a look at the processing flow, we can start at the left side. You can see there the picture with all our data sources. These sources can be on-premise sources or Azure or other cloud service sources like also AWS, Google Cloud, or other services. Then we have our ingestion, where we have our storage. It can be database, Hadoop ecosystem, storage accounts. And we have also supporting services like Azure Functions and Databricks. In the next step, we are going to do our data preparation, which contains validation and cleansing. And then we can do the analysis with the machine learning and Databricks and the transformation to heterogeneous model. In the last step, we are going to materialize this processed data to optimize it further for retrieval. And then, of course, in the last step, it can be consumed by reporting, by dashboards or other services. I will now give a quick overview of all different components within Azure Data Factory. Afterwards, I will show you quickly in a demo how it goes in practice. Data Factory supports a wide variety of services that you can connect with through creation of an object known as a linked service. This enables you to ingest the data from the data source to prepare it for transformations and or do some analysis on it. In addition, a linked service can fire up compute services on demand. For example, you may have a requirement to have an on-demand Hadoop cluster, for example, for processing data through a Hive query. Therefore, a linked service enables you to define data sources or compute resources that are required to ingest the prepared data. If we connect to our sources, we need also a compute node to support it. The ingestion, the integration runtime, the IR, is the compute infrastructure used by Azure Data Factory to provide for data integration capabilities across the different network environments. The first one is the data flow. It executes data flow in a managed Azure compute environment. It does also support data movement, can copy data across data stores in public network or in private network. There's also an activity dispatch, so it can dispatch and monitor transformation activities running on a variety of compute services such as Databricks, HD Insight, and many more. And it can also handle SSIS package execution. Data Factory offers 3 types of integration runtime, and you could choose the type that is the best serving data integration capability and network environment needs that you are looking for. The 3 types of integration runtime are, the first one is the Azure integration runtime that can be used when the activity is between Azure components. Then we have also the self-hosted integration runtime. This is the one that is used for activities with on-premise connections or to other Azure virtual networks. Be aware also that this is an important component, this integration runtime, especially if it's on-premise, and it must be scaled and have a high availability if you run it on-premise. Another important thing if you run it on-premise is that the integration runtime and the server or the servers that it is running on must also be patched manually. I know that we had in the past some experiences with it at the customers that where updates were pending but not implemented, and that's resulted in some latencies and troubles with the integration runtime. Then you have also the Azure SSIS integration runtime. This one is more used as in a lift and shift approach, where you move your on-premise SSIS packages to the cloud. It can be a first part in a cloud migration project, but at the end, I think the projects are going to replace it by real Azure components to benefit from the cloud advantages like scalability and other things. If you have the resources running in another Azure Virtual Network, then you can only use the self-hosted on a VM in the cloud, an Azure VM, or the SSAS integration runtime. Once your linked services are defined, you can also, did I miss? No, okay. Once the linked services are defined, Azure Data Factory acquires data through datasets object. Datasets represent data structures within the data store, and that's being referenced by a linked service object. Where the linked service is more handles about the connectivity and the security of your components, there a dataset is more fine-grained definition, like, for example, the file format and so on is within it. So datasets can also be used by Azure Data Factory process known as activities, and those activities typically can contain the transformation logic and the analysis commands of the Azure Data Factory's work. Once your linked services and datasets are created, then there are two components to handle the data. The first one are the data flows. Data flows are data transformations, for the data transformation, and the second one, and it will be shown in the next slide, are the pipelines, and those are more to process and orchestrate. In the Azure Data Factory, data flows are built on Spark using data that is in Azure, like in blob storage, Azure Data Lake Storage, SQL, Synapse, Cosmos DB. In Azure Data Factory, you can create two types of data flows. We have mapping data flows and wrangling data flows. You can use the mapping data flows to visually transform data without having to write code. You can focus really on the transformation and the logic, while Azure Data Factory does heavy lifting and lifting behind the scenes, and it translates your transformations and logic to code that runs on a scaled out Azure Databricks cluster in the background. You can also use wrangling data flows to visually explore and prepare datasets using the Power Query online mashup editor. And you can focus more there also on the modeling and logic in this approach. For the orchestration of our data processing, there are pipelines. A data factory can have one or more pipelines, and a pipeline is a logical grouping of activities that together perform a task. For example, a pipeline can contain a set of activities that ingest and clean data, and then kick off a mapping data flow to analyze this data, for example. The pipeline allows you to manage the activities as a set instead of each one individually. You deploy and schedule the pipeline instead of the activities independently. Examples of activities are like data movement activities, data transformation, control flow activities, and there are really many more. Azure Data Factory pipelines can also be started in different ways. You can start them manually. You can go to the GUI on the portal and start them there. Or you can also manually run the pipeline by using one of these methods, like, for example, the .NET SDK, Azure PowerShell model, the REST API, or the Python SDK. Or you can start the pipeline from a trigger, automated, and this can be done event-based or time-based. Okay, so to show you how this whole puzzle fits together, I will give you a little demo. Let me take my screen, my portal screen. Voila. If you want to open the Azure Data Factory, you first, of course, need to connect to the portal, and on the portal, you will see the data factories. And there you can, if you create a data factory, then you can open it from there. So I have my own webinar data factory in this case. And I just click Alter and Monitor to really start up the data factory. Of course, I have to authenticate to it. And then it will open for me the data factory. If it is the first time that you use Azure Data Factory, then you will the first thing you need to do that will ask you to do is to do the Git configuration. In this case, I already did it. You can see it's connected to the Azure DevOps Kit, which I used for this project. You can use DevOps Kit, or you can use GitHub or any other Git type if you want. Once this is done, you can start by creating your linked services. The linked services are also on this panel, and you can there create new linked services. I will quickly show you how to create a new one. So you can see there are a lot of types of connections you can create. If I quickly go through them, you can see there are really a lot of them. Let me, in this case, take the Azure Data Lake Storage Gen 2. I can continue. There you can give it a description. You can define the name for it. So you can give the link service the name that you want. That is more in detail a description of what it should do. And you also there define on how to authenticate. So first you can say that you use an account key. You can use a service principal, or you can use a managed identity, which is kind of a built-in service principal of the service. If you take that, you can also choose afterwards to use Key Vault to keep your secrets, to put your account key, for example, and put it there. And then per environment, you can have your own Key Vault and keep your secrets there. In the second step, so once the link service is created, then we go to our Author tab, and there we can create first data sets, then we can create a data flow, and then we can also create pipelines. For the demo, I already quickly created one, but you can always create a new one by tapping the three dots and then say, create me a new data set. Then again, you can use the type of connection you want to use. Let's, for example, say again, the Data Lake Storage Gen 2. And then you can see for the data set, you also have to specify which type of data do you want to receive. Is it Avro format? Is it Parquet format? JSON, Excel, and so on. So in this case, I took, for my demo, I took an Excel file. If you also want to make it more dynamic, instead of just having a fixed file, you can also click on this file, and then you can say, okay, add dynamic content. And then you can code it a little bit, and then you can say, okay, take this value from a variable that I did define, from a function that I use, and then you can start making it more dynamic. Once you have your data sets, most of the time it's like a source connection and a destination connection, then you can create a data flow. And the data flow is like going from a source connection, doing some handlings, and then finally, most of the time you want to put the result somewhere. So in this case, I have my Excel file, I do sorting on it, and then I put it in a sink. I put it in a separate Azure Data Lake Storage location where I have my sorted, maybe filtered file. Of course, there are a lot of actions that you can do. So if I take, for example, you can also make two parallel flows. You can specify the connection, and you can then simply add the type of thing that you want to do. So the transformations that you will or can do there are a lot of them. You can join, you can do and exist union tables, and many more. In the final result, I will delete this one again. In the final result, there you can create a pipeline, and in your pipeline, you can have also a different type of actions. You can call Azure Functions, for example. You can call Databricks. You can use notebooks or simple Python codes. You can call HD Insight, machine learning, whatever. Or you can also call your data copy or a data flow. So in this demo, I quickly took the data flow, and I referred, if I double click on it, to the data flow that was already defined. If you want to execute a pipeline, let me go back to the pipeline. We can trigger it. You can also debug it. If you debug it, it will just run it locally and it will not really perform it or show it afterwards as a triggered one. Or you can trigger it and you can say, okay, trigger now, and then it will execute it now, but it will also be monitored by Azure. Or you can say, okay, edit or create a new trigger and assign a trigger to it. Those triggers that you want to choose here can be defined if you go back to the Manage tab. There we can define our triggers, and then you can create a new trigger. You can say it's scheduled or a tumbling window. Both are time-based, or you can make it event-driven. You can say if a new file arrives, then process this file, and then it's already event-driven. I'm not going to change this one. If you did run your trigger or your pipeline, you can always monitor them and you can see all the results of all executions. If one was failed, I don't know if I have a failed one over here. No, not anymore. But then you can always, if go in detail, you can click on it, you can see the steps, and you can always see if there is a failure. You will have an extra button here to see what are the failures and see the details. So if I click here, I have the details, but there are no failures, but you can see that it has been processed. Okay, so that for the demo. I hope it already made it a little bit more clear. If you have some more questions, you can always put them in the chat, and then we will answer. I will answer after at the end of this part already. Another thing, if you want to make the orchestration more dynamic and thus also easier to extend afterwards, you can make your pipelines meta-driven. This is, of course, a little bit more advanced to implement to start with it. But once you have a framework to do this, you can expand and orchestrate it based on the metadata that can be stored in a database or in files like YAML or JSON. And at Micropole, we have Micropole Insight, we have our own Data Vault engine. And this is kind of framework that is based on Azure Data Factory. And we also use Azure Functions and Azure SQL, where we store our metadata. And that is used to import your data into your integration layer. And this integration layer, in our case, is Data Vault model, but it can also be, of course, any other type of modeling. If you want to know more about our A to C and Data Vault approach, you can also always contact us. As a last small point, I want to quickly mention Synapse workspaces. They are currently in public preview, but they will be released before the end of this year. So I guess they will be released in the next days or weeks. And Synapse workspaces will contain SQL pools, will also contain SQL on-demand and Spark pools. And to create an end-to-end data load and transformation pipeline, it will also contain Synapse pipelines. Those Synapse pipelines, if you hear of it, it is an exact copy or a 99% exact copy of Azure Data Factory, but integrated in the Synapse workspaces. Okay, I will, at the end of this part, already check if there are some questions at the moment. Let me open it. I see already one question. Can you use blob storage instead of data lake storage? Yes, of course you can use blob storage and data lake storage, those two. But in my opinion, I use more the blob storage to store pictures, media files, the unstructured data. And I use more ADLS for analytical workloads like data that afterwards need to be processed with machine learning, with Databricks or others processing on it. So for me, data lake storage, I use it more for also relational data and data that has to be processed, where blob storage, which is of course cheaper, is used for unstructured data. Okay, so if there are no more questions, then I will hand the word over to Glenn, who will talk to you about the workflow orchestration.
Hello, sorry, Egan. There are two more questions in the chat. So they aren't answered in the Q&A, but they put it in the chat. So Ruben has one question. He asks if ADF automatically allows to see which files are used in which pipelines. Impact analysis. So for example, if I change a file or a data source, which pipelines are impacted? So maybe if you can open up the chat, you can see that there are two questions there.
Let me check on the chat. There. Okay, I see. Does Azure Data Factory allow you to see which files are used in which pipelines? By default, no. The files underlying that are used by pipelines, you cannot trace them back. For more data governance and data lineage, Azure is working on the Babylon project, and there you might have the possibility, but that's also still in preview. I did see a demo a few weeks ago on Project Babylon, and there they will introduce more data lineage and data governance, but in this case it's about data lineage. So therefore you cannot do it directly with Azure Data Factory. So there you will need an extra component to do it, I'm afraid. Currently, there's no solution to see it directly, because also those files are copied and then will be removed. If you put them in a staging zone, for example, you copy them there, you process them, and then you remove them. So it's a little bit difficult. But what we do also with our Data Vault approach, because in Data Vault we put also a lot of metadata in it, there you can trace back always the files that are used and are processed. And if you have, like we do it in our Data Vault approach, if you have the metadata specified, you can also query the metadata to see which files are used in which processes, but then you have to do it yourself. See also a question, what is the difference between ADF and Synapse? Azure Data Factory is only an orchestration tool. Synapse is a tool where you can do orchestration, but you can also do a lot more. So there we have different pools. Currently, Synapse is only, what is available is only the data warehouse part. So it's the SQL pool, but in the future, in the upcoming weeks, it will also contain Synapse workflows, and within Synapse workflows, you can also define Synapse pipelines. You will have a Synapse Studio, you will have a Spark integration. So there you will have a lot more than we have currently with the Azure Data Warehouse, which it was before. So in the future, there will be more, but of course, Azure Synapse is more expensive, will be used. We only use it in very large, where we have large volumes of data. And if we have only smaller volumes of data, then we will use not a Synapse, but we will use Azure SQL, for example. And then we just use Azure Data Factory aside of the database. So yeah, it's you mentioned here, is Synapse a successor of ADF? No, Synapse will be a platform where they will combine a lot of components, but it will be more expensive and used with huge data volumes, where ADF will still be there and it can be used with Azure Data Factory, with Azure SQL Server and other smaller, you can still put terabytes of data in SQL Server. So the lower volumes, the not very high volumes, will first use, I think, SQL Server and then make use of Azure Data Factory. So they will always be there separately from each other. So it's not that Azure Data Factory will be integrated in Synapse and will not exist on its own. So there will be an integration within Synapse to facilitate it, but there will always, or at least in the next years, there will also be Azure Data Factory separately where you can use it with other components if you don't use Synapse. Well, I hope this is an answer to the questions. If not, you can always, of course, contact us further and then or ask some more questions in the chat. Okay, so Glenn, it's up to you now.
Okay, thank you, Egon, for the explanation about Azure Data Factory. I'm going to share my screen and take over. Okay, select the screen. There you go. Okay, so that was an interesting demo and answering questions about data flow in Data Factory. Let's now have a look more in detail on the things that are needed to deploy objects in Azure and with workflow orchestration in Logic Apps. So what is Azure Logic Apps? It is a cloud service that helps you schedule, automate, orchestrate tasks, businesses, and workflows when you need to integrate apps, data, system, services across enterprises and organizations. In the next few slides, we will talk about workflows, triggers, managed connectors, and actions. Within Azure Logic Apps, we also got Enterprise Integration Pack. This is for a more advanced integration scenario, and it includes capabilities like BizTalk self-server. But for this demo, we feel that it's out of scope. So Logic App is great for when you need a solution that has workflow-based integration. It scales up or down. It can handle business flows that require conditional steps, or allows you to create custom connectors around existing REST services. So what do you do in workflows? You visualize, you design, you build, you automate, and you deploy business process as a series of steps. First, you decide which pre-built components you need for your business process. Next, you use the design tool to build your workflow from these components. And the last step is you save your design and it will run automatically in the cloud. Triggers. A trigger is an event that occurs when a specific set of conditions is satisfied. So triggers activate automatically when conditions are met. For example, when a timer expires or data becomes available. Every Logic app starts with a trigger. There are many built-in triggers. For example, there are the Microsoft managed connectors that provides triggers that fire events or when new data is met. And each time the trigger fires, the Logic app engine creates a new Logic app instance and runs the workflow. We can have either scheduled or event triggered based. And the best practice is that after every trigger, we add a first step to see if it's already running. Next, a connector. So a connector is a component that provides an interface to an external service. It uses the external service's REST or SOAP API to do its work. When you use a connector in your Logic app, the connector calls the service underlying API for you. So this is very important. It calls the API. Logic app provides hundreds of pre-built connectors that you can use to create your apps. For the cloud, we have connectors like Office 365, blob storage, SQLDB, and so on. And for the on-premise, we have connectors like SQL Server, SharePoint Server, Oracle DB, and many more. Some connectors specifically support business-to-business communication and require an integration account that's linked to your Logic app. Before using certain connectors, you might have to create the connections, which are managed by Azure Logic Apps. These integration account connectors, they are available when you create and pay for an integration account. So they are not standard available for every Logic app. These connectors can then transform, validate XML, encode and decode flat files, and process business-to-business messages with AS2, EDIFACT, and X12 protocols. You can also create custom connectors. You can write them to access services that don't have pre-built connectors, but these services must have a REST or SOAP API. So the requirement that the service provide an API shouldn't be too surprising, since I just told you that the connectors are essentially wrappers around that underlying API. Next, we got actions. An action is an operation that executes tasks in your business process. actions run when a trigger activates or another action completes. There are all kinds of actions, for example, send mails, copy files, insert records, and so on. And each action usually maps to an operation that is defined by a managed connector. We also got some control actions. These are special actions that let you make conditional decisions or repeat a set of actions. And then we think about switch statements for each loops and until loops and so on. So let me show this in practice. I'm gonna open one too much. I'm gonna open up the portal. Looks the same as with Aegon, but now we are going to go to Logic Apps. I just created a Logic app for this webinar. And as you can see, it's fully blank. So we're going to start from 0. We're going to create a blank Logic app. And we are going to go for an HTTP request. This is easy to use for demoing purpose because we can now trigger the run manually. So when we are going to visit the URL that the Logic app is going to give us, we can start a run, a manual run. What are we going to do? So we are going to change the method, as I prefer to use get instead of post. And you'll see the URL will be generated after a save. At the moment here, you also see that post URL. When we save, this is going to change. So as you can see, we created an URL and it's changed to a get method. Then we are going to add a new step. Maybe let me show you all the connections real quick. So as you can see here, we got the actions. So the action is that the operation that executes a task in the business process. And we got a lot of them going from Amazon to Apache to AS2. So really a lot of them. You can keep scrolling in here. There are a lot of built-in things. Also, you got the control actions that I just told you about, the switch, the loops, and so on. And you also got the triggers here. So the trigger, like I just said, was an event that occurs when a specific set of conditions is satisfied. So this will activate automatically when the conditions are met. So what can we do? We can, when a work item is assigned, stuff like that, Azure queues, when there are messages in the queues. So a lot of stuff that we can do. For the demo, we are going to give a response on our HTTP request. So we're going to look at a response. Built in. Okay, it doesn't look it for me. Choose a response. Here is our response. So, and what are we going to show on the page? We're going to show hello viewers. So we are going to save this, and we are going to copy the URL, and we are going to run this. So now we are triggering our web app to run. Okay, and now if we go to the URL that we just copied, we will see the message, hello viewers. So the first part is done. Now, when we go back to the designer, we can start editing this. So for example, let's say that we want to parameterize this link. We're going to add a relative path here. So the relative path is here, and we are going to add the first name, because it's always nice to say hello and then add the name instead of viewers. So this is, we are going to run it. First save it, of course, and you will see, look at the link, this will change. Because now we add a relative path in there. And as you can see, where is it here? So we invoke with the relative path our first name. So let me take this again. we're going to put here, just for the demo, manual Egon, but it hasn't changed yet. And why is that? Because we didn't adjust our response. So what we are going to do here is say, hello viewers. We want to say, hello Egon. So when you click here in the body, you can see the dynamic content open up, and here you can see all the parameters that are created. So now we edit Egon as a name, and if we now save and refresh the page, we can see hello Egon. So this is one way to parameterize your actions and your triggers. You can also create some general parameters in here, or create a last name, which is of course a string, and we're going to add the name of Egon like this, and we're going to close it up, and then we are going to add here, it's in a different section, but here the parameter last name. We're going to save it again, and after this we're going to refresh this, and we can see hello Egon van der Red. Okay, this is fun, but now maybe do something useful with it. We're going to add a new component. So here you can either choose to create an action or a parallel branch. I will just show you the difference. First, I'm going to say I'm going to send a mail with Office 365. So send an email. And here I can say to .be. I'm going to say test. I'm going to say hi. Of course, the parameters, they're not here, but if we click see more, they show up. So we're going to say hi, Egon van der Red. How is the webinar going? I'm also going to add a new parameter, a copy, and I'm going to send the mail to myself as well, so I can show you guys. So save. And if I'm going to refresh the website here, it will load a little bit longer. And what will happen is that we will receive an email which sends a mail to Egon van der Red with a copy to myself that says, hi Egon van der Red, how is the webinar going? So as you can see, you can create a lot of stuff with it. I'm going to show you the parallel branch as well. So you can start in parallel branches where you can go either way, and you can create some built-in controls that has some conditions. So you can really create an advanced logic app if you want. So some other things that I want to show you is when I go to the workflow and I go to the overview. So here you have the designer, which we were working on. You can also check the code view, which is in here. Of course, you can then create templates and you can publish it to other environments. You can put it in the ARM template as well. You also got your versioning in here. So Azure Logic App keeps versioning for you. Also, you can see the runs in here. So all the runs that we did today, they are in here. I think that is the most important stuff in Logic Apps for now. So let me go back to the presentation. So when I was working with Logic Apps, I couldn't help myself to think that Logic Apps was the same tool as Power Automate. Maybe some of you know it, Power Automate, or maybe know it by the previous name, Microsoft Flow. In the past, I was working with Microsoft Flow for our Power BI Insight tool. And when I started working with Logic App, I was thinking like, they look the same, but are they the same? And they are the same, but they serve a different purpose. So let's compare them real quick. Logic Apps is more PaaS, while Power Automate is a SaaS service. And for the Logic App, you require an Azure subscription, while in Power Automate, you do not. So it's linked to the certain Office 365 user, and it is part of the Power BI suite. So with the Power BI and with the Power Bots and stuff like that. While Logic Apps is just linked to the Azure subscription. It can call Azure functions. It's linked to a resource group, and it has some source control available. So there are some different stuff between the two components. Okay, so this was it for my part of the demo. I'm going to see if there are any questions left.
Yeah, I also see that we went a little bit over time, but I see there is.
Okay, so I see there is one question already. So the question is, does Logic Apps allow for streaming scenarios? It's possible, but it's not ideally for that. So there are other tools in Azure that are better suited for this task. For the streaming, we typically advise event hubs or even other options like Kafka or Databricks. And we talk about streaming in our first webinar. So if you want to check that out, you can. But if you want to really do streaming in Logic Apps, you could probably do it and write an Azure function that reads the data and stores the data somewhere. And then this function can be triggered by Logic Apps or by ADF run that runs each 3 minutes. So it's possible, but it's not the ideal service to do that. I don't know if there are any other questions in here.
I don't see
But
any.
don't hesitate. If there are any questions coming up after the webinar, you can reply us by mail. You can send us a LinkedIn message and we will try to answer your questions as best as possible. So if there are no other questions, I'd like to say thank you very much to joining, and we hope you have a more clear view and understanding of workflow and data flow orchestration. And after this session, you will also receive an evaluation form, and we are really looking forward for all the feedback from you. And we also hope to welcome you on our next webinar, which is a second session on continuous integration in Azure, and we will demo the CI/CD components in DevOps. Thank you for attending this webinar.
Okay, thank you again. See you later. Bye.
Bye. Hallo? Achim is hier nog? Egel, jij ook?
Ja.